of the company. And then Curtis is my counterpart. He and I cover the Southwest together. Curtis has over 25 years of data experience. He's been in Fortune 500 companies, energy, telco, manufacturing, media and entertainment. He's worked for Teradata, MongoDB. So he's got a ton of expertise in the data area. Martine's going to go through the story. Curtis is going to give you a quick high level on Starburst, and then we'll field questions as we go here, and we're happy to open it up for more Q&A or discussion at the end. So I'll drop those links into the chat here in just a few minutes. Thank you all again, and with that, I'll hand it over to Martine.
All right, thank you, DJ, and thank you, Joe, for inviting us. Let me turn off video to avoid distractions. And you guys can see the slides, right? Just to make sure. Okay. Okay, so let's do a quick overview of what is Presto for those that are not maybe not familiar with it or may not know enough about it. So Presto is a dedicated SQL query engine. We built it from the ground up for speed and scale, and we've proven it at a very large scale with thousands of users at a bunch of different companies, like specifically at Facebook, where we incubated it, and then at other big companies, internet companies that ended up using it over the years. It's an open source project. It's been around since 2012, and it has a very large and very vibrant community of users and developers all over the world. So unlike a traditional database, Presto decouples computation from storage. And it does this, I think someone needs to mute some background noise there. Right, so it decouples computation from storage, and it does this via a connector architecture. So there's a way to plug in connectors for different backend systems. And this allows a Presto cluster to read data from a variety of data sources, such as different object stores like Amazon S3 or Google GCS or Azure Storage, or even relational database or NoSQL databases. So separating the storage from the computation brings a bunch of benefits. Like, for instance, it's possible to scale the storage layer independently from the computation layer. And then Presto can query data where it lives without having to rely on processes or tools to copy data from one place to another, to migrate data from one place to another, or what's traditionally understood as ETL processes. And then finally, Presto can run anywhere. It can run on premise, it can run on any cloud, it can connect to different storage backends, but it's generally agnostic about the environment it runs in, which makes it easy to migrate from one environment to another and to avoid getting locked into any specific technology of infrastructure. Presto is used by companies all over the world, small companies, large companies, and across many industries. There are companies from the consumer, internet industry, retail, manufacturing, healthcare, finance, and so on. Let's talk about the history of the project briefly. We created Presto in 2012 at Facebook, and it was just a team of 4 people. That was David Phillips, Dane Sandstrom, Eric Huang, and myself. We wrote the first line of code with the eventual goal to make it open source and to build a community around the project, which we ended up doing in late 2013 when we open sourced it. After that, there were a number of companies that got involved in the project. Notably, in 2014, there was a team led by Justin Borgman, the current CEO at Starburst. They were at Teradata at the time, and they started engaging with us and the rest of the community around that time. They ended up becoming the first company to provide commercial offering of Presto and commercial services and support. Then in 2017, that team left Teradata and founded Starburst, which is now the Presto company, which is dedicated to commercializing and advancing the Presto technology. And then in end of 2018, Dane, David, and myself left Facebook to focus full time on the open source project and on the community. Basically, we worked to get the community to grow, to consolidate it, to make sure other people and companies were involved in the project, and basically generally making sure that Presto was a successful project outside of any single company. Then in late 2019, we ended up joining forces with Starburst, and here we are now. And very soon, the final member of the original team, Eric, is going to join us as well. So why did we build Presto? There was a famous phrase, at least internally at Facebook, from one of our data scientists, which he basically said, a good day is when I can run 6 Hive queries, which seems like awful and horrible. It's like if you can only do that kind of work in a single day, like that must be a very painful work experience and unproductive experience. So we thought we had to do something about this. At the time, Hive was the engine of choice for all data analysis at Facebook. And if you're not familiar with Hive, it can be very, very slow, inefficient. So it ended up being a huge productivity drag. So it was primarily being used for ETL and for transformation workloads. But because there was nothing else available for doing analytics, people used it for what you would normally think of as ad hoc or interactive analytics and workloads. There was another system that attempted to address some of those issues, but it wasn't designed to scale, or it wasn't designed to evolve in the way that was needed to support all the complex functionality and workloads we need to support. So in good Facebook tradition, we decided to start from scratch and create a new query engine from the ground up. So there were a couple of goals that we set up for ourselves. The first one was that, of course, it had to be fast. Like in order to support interactive analytics, we had to be able to Presto had to be able to return results very quickly, but it also had to produce correct results. There was a notion at Facebook at the time that for a system to be fast, you had to trade off correctness for speed, and we wanted to challenge that. Many of the systems at the time achieved that by sampling data, skipping data, maybe like if there were, if reading data from some systems were slow, it would just skip it and keep going or something like that. So at the end of the day, you end up writing queries that produce results that you couldn't trust. You couldn't know whether they were correct, they were even approximately accurate or not. The second goal was, of course, it was like a non-negotiable requirement. It had to be able to run at the scale of Facebook at the time. And then, of course, it had to be able to keep up with the growth of the company. Usage of Presto and in general, usage of tools like these is correlated with the number of employees. So when we started, there were about 3,000 employees at Facebook. And then by the time we left in 2018, there were 35,000 employees. And so it grew like by an order of magnitude, but it wasn't just in the number of employees, but the usage didn't grow at the same rate, because by making Presto faster than Hive, it enabled, and by supporting a bunch of additional use cases, it enabled people to do their work more efficiently, so they want to do more of it. So it just unlocked the ability for people to do more stuff. The third goal was to use standard ANSI SQL as the interface to Presto. This was a bit of a controversial decision at the time, because everyone was familiar with Hive, so they wanted to keep using Hive dialect and functions and the semantics. And so there was pushback around that. But our hypothesis was that the majority of all the future employees at Facebook that we're going to hire were not familiar with Hive. They were likely more familiar with other commercial database systems and analytic systems like I don't know, relational databases or systems like Teradata, Netezza, Vertica, and so on, which tend to stick to dialects that are much more closely aligned with the standard, with SQL standard. So that ended up being a good decision in the end. And then, of course, by supporting standard SQL, it makes it much easier to integrate with third-party analytics tools and BI tools like Tableau and MicroStrategy, which were actually popular in some organizations within Facebook. And eventually, we were able to use them with Presto. And then finally, we wanted to make it open source. Some of us in the team had a lot of experience with open source projects. We had used open source, we had developed open source, and we had the firm belief that open source software ends up being the most robust and successful over the years and in the long run. So, and we wanted the same thing for Presto. And by getting other people and companies involved, we had a chance to build something that that transcended one single company and could satisfy the needs of a lot more people and a much larger audience than what we were building at Facebook alone. All right, let's talk about some of the things that happened over the last year and a half in the project. We've seen a tremendous growth in the community over the past 18 months. And of course, that correlates with the number of improvements to Presto itself. As of now, we have more than 2,700 people in our Slack group. And out of that, there's about 350 or more that are active every single week. And this is a group of developers, users, and all interacting together in that channel. It's like people have questions about Presto, people are exploring Presto, people that want to contribute to Presto, and then of course the community of developers that are there to help people out. So if you use Presto, if you're interested in Presto and you haven't joined, I would highly recommend you do that. It's a very open and welcoming community. And so since the project started 8 years ago, we had more than 400 people contribute to the project. And in terms of code, that's what I mean. There are a lot more people than that contribute in different ways, like evangelizing the project, helping other users, providing feedback, which is actually super helpful, like for us and for the group of developers to understand what problems and issues people are facing is very important, because it helps us decide on what to focus on next. And it can, I mean, sometimes it can act as kind of a forcing function, or it can fire under people to go and do things. So that's super important. And then one important thing, and kind of a testament of how quickly the community has grown over the last year or so, is that somewhere between 25 to 30% of all the changes in the project have happened in the last year and a half, which is an acceleration over previous years. So we've made a number of improvements to Presto across multiple areas, all the way from new language features, improvements to the query engine, performance optimizations, and very importantly, security improvements and features. So a couple of notable ones, like support for variable precision datetime types, which allows Presto to process temporal data with higher precision than it was possible to before, down to nanoseconds or even picoseconds, which are, I mean, it seems like a simple thing, but it's actually a very important feature for companies and organizations in the financial sector. For example, we have some users like FINRA, which deal with stock trades and stock data, and that tends to have higher precision than milliseconds, and they need to be able to operate on that. So that's super important to them. Then there's a very important feature that we added recently called dynamic filtering, which is an optimization in the query engine that can speed up the execution of queries that involve very highly selective joins, and they can improve by orders of magnitude in terms of performance. So I'm not going to cover everything here. Just I wanted to give you a list and a highlight of a couple of the improvements there. Then we also had we already had a pretty good selection of connectors to external systems. And over the last year and a half, that list has grown pretty dramatically. We have new connectors for Elasticsearch, some other open source projects like Apache Phoenix, Iceberg, Druid, and Pinot, and even some commercial systems like Google BigQuery, Oracle, and even Google Sheets. You can run queries, you can run SQL queries against Google Sheets and join the data against other data sources if you want to. All right, in terms of what's going on right now, so these are some of the projects the community is working on. One thing to keep in mind is that this is an open source project, so the roadmap is driven by what members in the developer community are willing to invest time and resources in. So some of the main focus areas are around performance, improving connectivity with external systems via connectors, and making the system more capable and flexible. This involves usability features, new language features, and capabilities. There's a couple of notable ones like the ability to push computation into the source system whenever possible. And this can be useful for improving the performance when querying like relational database, for instance, where it's like you can write a Presto query and Presto can send to the data source a subset of the query that the data source is capable of processing. So this can improve performance, it can reduce the amount of workload that Presto can do, and it can take advantage of capabilities in the remote systems. And then there's another improvement that we're working on. It's gonna hopefully land pretty soon, which is support for transparent translation of Hive views. And this can make it very much easier for people to migrate from Hive, or for example, if they're running mixed environments, it makes it possible to run Presto queries over Hive views. Which the problem with that is that those Hive views are defined using Hive's syntax and semantics, so Presto doesn't inherently understand it. So with this feature, it will be possible now to translate for Presto to translate transparently and be able to process them. That's kind of my yep.
Sorry, we got a question here, sort of along those lines. Is there going to be a Snowflake connector on the roadmap?
There is a Snowflake connector provided by Starburst, which is actually a high performance connector, so that's available. And there's also a work in progress from a member of the community to add Snowflake connector for the open source version as well.
Awesome, thank you.
Okay, and so that kind of covers like the overview I was going to give. Now, so Starburst is built on top of open source Presto. So now I'll turn it over to Curtis, who's going to give you all the details about it.
Thanks, Martin. You guys hear me okay?
Okay, let me stop sharing here so you can go and share your screen.
And everyone should be seeing my screen. Same slide that he just stopped on. I moved to the agenda slide. Can you guys see that?
Yes.
Awesome. Yeah, so I'm gonna dive into a couple of things. We're definitely gonna dive deeper into Starburst, the Enterprise edition of Presto, and what we offer over there. And I want to start a little bit talking about the different data personas and the journeys and challenges. I think most of this group will probably relate to what I'm going to say on that front. We'll talk about how organizations dole out data access these days, and talk about the mind shift that benefits those organizations. And then we'll wrap up with some best practices and some use cases, use case examples for Starburst Enterprise Presto. So let's start by talking about these three personas. This is kind of how we think of it, and I'm sure there's overlap in some organizations. But generally speaking, you have a person from the business, fairly high up in the organization, who's asking very high-level questions like how much inventory we should buy, or which customers we should be targeting. And so that question leads, generally it rolls downhill to a data analyst, someone who may or may not have the skills to write queries, but certainly knows their way around the organization in terms of data and business processes. And this person establishes, what they need to go get in order to answer that question. And then that usually involves someone from a data team, more of an IT organization. It's either going to, from an infrastructure standpoint, give them access directly to the data, or more likely than not, is going to point them either to a system that already has that data, or inevitably, we see this, they're going to end up having to create new ETL in the data warehouse or the data lake in order to load this data that the data analyst has identified for the new question. And the problem is that this often turns into a weeks-long, months-long, I've even seen year-long or more projects to go get the data, figure out what data has changed, to calculate, some kind of delta processing, set up a routine batch job to load the data into the data warehouse or data lake. And so then, the data analyst sits and waits while IT does this. And so, weeks or months or a year later, they finally get access to the data, and they build a report, or maybe the report's built for them by IT, but they finally get their hands on this report and they do some analysis, hopefully, and they go back and give the person on the business side, rolling back up the right side of the screen here, they go back and give the person on the business side the answer, and he or she kind of shrugs their shoulders and go, what was the question again? Because it's been so long, since the question was raised. Business changes fast, and ETL processes, unfortunately, sometimes take quite a bit of time, to complete. So there's three basic methods here that we talk about that you can use to grant that access to data. I talked quite a bit about ETL there, the number 2 point here, but you could, and we often see with data science type folks, that you can give access directly to directly to whatever their tools are. If they have a BI desktop tool like Tableau, or if they're using Spark or Jupyter Notebooks or what have you, you give them access through the tools. ETL comes up more often than not. And then there's a third option that I would say really has been around for a long time, but wasn't a real option until recently. And that's to grant some type of federated access through an abstraction layer, something like Presto or Starburst, where the data analyst has direct access to the data, but through that single point of access. There's some challenges with the first two techniques that we address in Starburst Presto. The tools challenges, we've got them kind of the 4 S's here: security, scalability, standards, and strings. With security, you can imagine if you have 25, 30 different systems and you have 100 analysts, that's a lot of security that has to be gone. You have to go out and individually grant, potentially. You certainly have to monitor that security when you give those analysts access to data. And so, very decentralized process there. Scalability, the other thing is on the tools front, the desktop tools, stuff like Tableau, they don't handle, a lot of data. They certainly don't handle a lot of users very well. And so that can become a challenge, especially for large scale data sets. Standards is an issue. If you can imagine, if some of your data is sitting in Hive, some of your data is in MongoDB in a NoSQL type store, and some of your data is in a relational database, even the relational databases don't all speak exactly the same dialect of SQL. And they also don't have all the same data types. And so, for a desktop user to try to bring those data sets together, there are challenges that they run into with that. And then finally, we call this one strings, and it's just this whole thing of having to have some credentials and some connection strings. And, if something changes on one of your source application servers, then you end up having to deploy, a whole bunch of new information to a lot of people. And it gets to be kind of a management challenge. On the ETL front, I've got kind of the 4 Ds here. The first one is we really just talked about this, right? That the ETL is difficult. It takes a while to create. I think it's gotten easier over time, but it's still, the reality of it is that you can end up with months and months of project work to ETL new data into the system, into your data warehouse or data lake. The other challenge is that it's all copies of existing data. And so, especially when you start getting into situations where departments go off and do their own thing, then you end up with, just multiple copies of the data all through your organization. And that's raising money, raising costs, not just on the storage front, but on the whole, the maintenance front, on the network infrastructure front. They're really just driving the IT budget up. The third thing in the D's here of ETL is the fact that the ETL is typically delayed. And sometimes that's okay. I think of ETL as kind of trading off query time for load time. But those delays sometimes just aren't acceptable given the nature of the analytics you're running. Some things do need to be queried in real time. And traditionally, these ETL jobs end up being batch processes that run at night and don't always have the latest information. And then finally, of course, deficient here. It's more often than not, the business is thinking up new questions, and inevitably they're thinking up data sources and information that you haven't already loaded into a data warehouse or a data lake. Everybody's been trying to solve that for many, many years, but I don't think anybody out there has truly ever finished building their data warehouse. But yeah, so just a typical data warehouse, lots of ETL in and out from all of these different various sources. What I want to talk about, and what we're about here at Starburst, is the federated access method. And we think this is kind of the new nirvana for data analytics. And I really feel like it started with the separation of storage and compute. You no longer have to load everything into a single location in order to query it. And so now with Starburst, you provide just a single database connection string, and that you give that to the Starburst Presto software, and that goes into a catalog. And to the end user, it just looks like another schema, essentially. And it looks like you're connected to one big system when in reality, behind the scenes, the server code is connecting to all of the data sources you defined. Through Presto, you can query using ANSI SQL. Martine mentioned that. And that it doesn't matter what the data type is. So for example, we have a MongoDB connector, and I can write SQL against the JSON data that sits over in the Mongo database. We provide some functions to deal with some of the nuances of JSON, but it's still SQL. It's a language that most business analysts, data analysts are going to be familiar with. And then finally, you can add data sources very quickly. It's a matter of a configuration exercise rather than doing some type of ETL project. So Presto helps solve these things in these three different categories. The first being the data access problems. Gives you the ability to quickly add sources, access dissimilar data. It doesn't matter whether it's Kafka, SQL, NoSQL. And then you're getting the latest information from whatever system you're connecting to. So it could be a data warehouse or a data lake that you're connecting to. But it could also be an operational system if if there's justification to run the analytics against that system. The second thing is query language problems, and as I mentioned before, just about every database out there is going to have some slightly different dialect of SQL. And the beauty with Starburst Presto is it's all the same SQL language. We take care of any translation that needs to happen when going against those sources, these different types of sources. And then finally, centralized access problems. We provide a highly concurrent system. As we get into the architecture a little deeper here in a bit, you'll see how the architecture of Presto and Starburst Presto works, so that we can scale. And then again, a big thing that you have centralized security access. You don't have to go independently manage that. So I think we talked about this before. It's a distributed ANSI SQL engine that gives you a scalable single point of access. And then I like this point, by the way, about preserved optionality, because most of the data warehouse vendors out there will tell you the solution to your problems is to load all of your data into their system. And I've certainly, in my time at Starburst, talked to customers who have been trying to make the transition from one data warehouse system to the other, and they're just going from one set of handcuffs to the other. And so the beauty with Starburst Presto is it doesn't matter where your data sits, we can query it. You can move it around. You can not move it around. You don't have to. You've got options. So here's a bit on the architecture, and how this works basically is the end users connect, with some type of tool that's generally JDBC or ODBC compliant. It's going to use a driver to connect. They connect to a coordinator node. There's typically one of these in a high availability cluster. We can have a second coordinator node as a standby coordinator. But the work of the coordinator is pretty lightweight. It's responsible for a couple of things. It's going to, of course, make sure that the person signing in is authorized and is properly authenticated. It's going to check the syntax of the SQL that they've issued, make sure that that all of that is properly formatted. It's then going to work with the different connectors, the different types of databases to go get statistics. And this is something that's unique to Starburst Enterprise Prestos. Our connectors, many of them have the ability to actually pull statistics from the source database. And so the coordinator can use those statistics that you've taken on those systems, can use those to develop a proper query plan. So once the coordinator has built the query plan, it then sends that work out. It breaks that up into pieces and sends it out to these worker nodes. And for some worker nodes, there'll be a single serial connection to the source database. But for some of the connectors, and we'll get into this in a moment, but for some of the connectors, many of the ones for the big data warehouse type platforms, they actually run in parallel. And so you'll see some of these workers will, or rather, you'll see some queries where every single one of these workers is making a separate connection to each of the nodes in, for example, your Teradata system. And so you get the benefit there of breaking the workload into smaller pieces and scaling out. And by the way, I didn't mention it, but you can have a Starburst Presto cluster anywhere from a single node with both the coordinator and the worker out to thousands of these workers, and it's very easy to scale it. There's no movement of data involved, and so we do things with Kubernetes and CloudFormation and whatnot to just simply add the compute resources. So coming back to kind of close the loop on the personas, the end result of Starburst Presto here is the business users get quicker answers. The data analysts get a single federated point of access that they just connect to one system essentially to get access to everything. And for the DBAs and data team, they get to focus on, I'm not going to say they never do ETL. There's certainly cases where you're going to do ETL, but they get to focus on the high value things where you need the performance gained by ETL, and they don't have to do ETL for every single business question that comes in. So let's talk connectors. I think someone mentioned earlier the Snowflake connector. We do have a Snowflake connector. It is a parallel connector, so it's enabled with stats, and it also connects to in parallel to the resources. So each worker is going to connect to some number of resources on the Snowflake side of things. Same is true for Oracle, for Teradata. The Teradata will actually be an AMP by AMP for those that are familiar with Teradata. So this is one of the big value adds, is that we at Starburst, we've really invested in taking this to the next level and making these connectors parallel. We also have, of course, some NoSQL examples here with MongoDB and Elasticsearch, Cassandra, and so on and so forth. Some of the drivers, as you can see here on the right, have the ability to do user impersonation and authentication pass-through. So you can log in with a specific user ID into the Starburst Presto cluster and actually have those same credentials used downstream as you connect to your Oracle Postgres, so on and so forth. And then, like I already mentioned, the cost-based optimizer is able to leverage the statistics taking in this list of databases. So some of the advantages of Starburst Presto for a data analyst. Providing a single connection string rather, for BI tools or whatever the tools are. They can build automated dashboards. They can do ad hoc queries using Starburst Presto. And the data analyst can access news sources anytime that those are added to one of the source databases. There's no import process or anything that anyone needs to do once a new table is added or a new schema is added to that system. As long as the connector is built into Presto, then it's automatically going to become visible in Presto when it's created. Here's an example of some of the BI tools that our customers have used. Pretty standard list of things here, and not all inclusive, because really anything that does JDBC, ODBC is going to be able to use our driver. So let's talk about data scientists. This is kind of the data analyst persona, but somebody that tends to be a little bit more DIY on the data wrangling front. You know, one of the big things here is you can write queries that the Starburst Presto cluster can process for you in parallel. So you're not doing all of your heavy lifting on a laptop or in a tool that maybe isn't ideally set up for high volumes of data. You can query those multiple data sources very easily using just a single connection string and ANSI SQL. And you're literally in the from clause while you're writing your ANSI SQL, you're literally saying from database.schema.table, and it takes care of the joins. It's, again, like it's just, I can't emphasize it enough. It's like it's a single system. And then finally, again, the security point here that, you know, for the data scientists who maybe need access to sensitive data, but they don't actually need to see that data, they just need to do some matching. We have all sorts of capabilities in terms of masking and hashing sensitive data as it comes in. And so these are some of the data science tools that our customers have used. So Jupyter Notebooks, RStudio, TensorFlow, you know, some of the most popular ones here. So for the DBAs and the data teams, the advantages. So the first one I mentioned is, you know, the ease of adding a new data source. It's just simply adding a configuration, a couple of lines of configuration information, generally speaking. It gives you a single point of control. And by the way, it also gives you, I don't know if I mentioned this before, but it also gets you auditing capability and logging capability in one place. So if you need to do an audit to figure out whether or not a data breach has occurred and whether or not, or to figure out what information might have actually been compromised, if the access is handled through Presto or through Starburst Presto, and this is a Starburst only feature, the auditing and logging is all in one place, and it just greatly, you know, greatly lessens the burden of doing such an audit. And then the other thing is that you can scale this up and down as needed. So you can actually, you know, start very small, maybe during peak periods of peak workload, scale the environment up, and then scale it down. It's very cloud friendly, right? So it's the whole idea is scale down when you're not running queries to save money, and scale up to get the performance that you need. And so, yeah, this is all about evolving, you know, the old nirvana of a single source of truth. You're now evolving to the idea of a single point of access. And so, you know, everybody accesses through this the Starburst cluster through a global security layer. They get access to all the data in your various data warehouse systems, your systems, whether they be SQL or NoSQL or object store. It's a single interface, a single language.
Hey, Curtis,
Yep.
There's a question out there. How does Starburst or Presto integrate with Druid's real-time query engine? And are Druid queries intermediate? So Joe, do you want to clarify that?
Yeah. So Druid obviously provides a way to query data, you know, from real-time data sources. Like, and I saw that Druid had an integration with Presto. Like, if I were to use Presto as the sort of the interface, would I be able to basically get the same real-time response out of Druid that I would have just querying Druid directly? Does that make any sense at all?
I can take that. So in general, the answer is no. because when you run a query against Druid, Druid can use internal data structures and the way data is organized internally to sort those queries efficiently and very quickly. What Presto gives you is the ability to use all the features of standard SQL and all the features that Presto supports over your data in Druid. Druid has a very limited query language, and it only allows you to do simple filters and aggregations and so on. With Presto, you can take that data, join it against something else. You can even join two Druid tables if you wanted to. So it's more about enabling use cases than trying to beat Druid in performance.
Okay, thank you.
Thanks, Martin. Okay, so just double clicking a little bit into the data consumption layer, the architecture here. So you start with your end users. Again, they issue ANSI SQL, anything that's JDBC or ODBC compliant. Go through the process I described a moment ago, so I won't spend a lot of time here, but parse, use the cost-based optimizer to optimize the query, and then send the query out to the workers. And then the workers run the connector software. It's a plug-in type technology, and they go out and connect to the various data sources, bring the data back into the workers. There'll be some communication between the workers, and then finally the results set up to the coordinator and back to the end user. So just to recap the differences between the open source version of Presto and the Starburst version of Presto, what we add from an enterprise standpoint, it falls into these 5 major categories. The first one is performance. Performance with Presto open source is certainly great, and the original intent of it was to be able to run more than 6 queries against your data lake in a day. And it does a great job at that. But what we add to that from a performance standpoint is the federated use cases where the connectors actually have statistics, and we can enable those cross-platform queries using the cost-based optimizer. And so I have an example here of a customer that went from open source to the enterprise edition and saw some heavy-duty performance improvement as a result of that. There are some connectors that are only available in the enterprise edition, and I think we kind of alluded to that. And then, of course, those connectors typically fall into the category of being something where they either have the optimizer statistics or the parallel capability, or both. Security is a big one. We provide the Kerberos and LDAP integration from an authentication, authentication standpoint. But then we also give you fine-based access control, data encryption, data masking, and query auditing. And by the way, when I say data encryption, I'm referring to the encryption in flight, because we don't actually store data in Starburst Presto, but some of the data, as it's being transferred from the source database to the end user, it does indeed need to be encrypted, and that's taken care of. We offer some enhanced management capabilities. So there's a tool called Mission Control, and some other tooling available that allows you to configure your cluster, to auto scale your cluster up and down, to fail over to a coordinator if there's a failure, and to monitor the general health of the cluster. And then, of course, we have multiple deployment options through the management interface. You can deploy to AWS with CloudFormation template. You can deploy to Kubernetes in all 3 of the major cloud providers, and we also support OpenShift services.
This is Hugo's
I think somebody doesn't realize it, but they're not on mute. Thank you. And so the final thing is, this is a big one, right? The support. We've got now we have the 4 guys who started all this work at Starburst. And we have the largest team of Presto experts in the world here at Starburst. And so some of the things we do with our employed staff, we make sure that each release is fully tested, that it's stable. We are constantly looking for bugs, and we're getting that feedback from customers, and we're releasing hot fixes and security patches. And then, when you use the Starburst Enterprise Presto, when you license it, you get 24/7, 365 days a year.
Hey, Curtis, we have a couple questions here. Assuming a federated approach, what options are there for handling heterogeneous joins?
I think you're talking about cross-platform, and I can actually show you here in a moment what that looks like. In fact, I'll bring it up on my screen. I've got an example of a heterogeneous join, if I'm understanding the question correctly here. And so this is an example of a query where some of my data, my customer data, is sitting over in S3, and so I'm actually connected to the Glue catalog for that. I have some account and product profile information that's over in SQL Server. And then finally, I've got some customer profile information that's sitting over in Postgres. So it's as simple as that. You build the connections to those systems, and then you write the query as if all that data was in one system, and we take care of it. Does that answer your question?
Yeah, that's great for the kind of the mechanics of the query, but can you tell it like, hey, I don't want you to move this table, it's too big, or kind of like Teradata does its bit with distributing smaller tables to all the amps and joining to the larger table that way, that sort of thing, or is that all automatic? Do you handle all those details?
So I'm going to say, Martine, correct me if I'm wrong on this, but I'm going to say for the most part that we handle those details. The cost-based optimizer knows when to when to broadcast something or when not based on the size of it. But one thing that you said there about moving data, I want to make sure is absolutely clear, is that we don't move data. So you'll hear from some tools that are labeled data, not data federation, but data. Oh man, I'm drawing a blank on the term now. Data virtualization tools. Yeah, where they'll actually copy data between platforms before they run the query, and they'll rely on those other platforms to do the processing. We actually do the processing in the cluster. So we're gonna write a query. We are gonna apply some things like filters. We're gonna push those down to the source database so that we're lowering the amount of traffic that happens over the network, and we're lowering the amount of memory that you need in our environment. So we are going to push some of the work down, but the data is going to come into memory into the Presto cluster. It's going to be processed there, and it's going to be sent to the user. So there is no real data movement in the sense that you might be referring to there.
Excellent, thanks.
Yep. I think there's another one out there.
Can I add a couple of things there? So in addition to filters, like when running queries against external systems, especially relational databases, Presto can push down more complex operations. For example, it can submit aggregations. Let's say you have a query that joins the result of two aggregation queries. Presto can push the aggregations into the data sources and let those systems do the aggregations and just provide the summarized data to Presto. And then Presto will take care of the rest. Then in the case of connectors like the Teradata connector that Starburst offers, we have an implementation that is parallel. So Presto can break up the computation of the query and read the data from Teradata across multiple Presto workers and do that in parallel and therefore improve performance with that.
Awesome. Thanks, Martine. Let's see, there's another one here about GCP stack driver or ELK. So I would say from a logging solution standpoint that, again, Martine, keep me honest here, but if we can do JDBC, if you can connect to it through JDBC, we have a generic JDBC driver that can connect that way. If you can move the logs into an object store like S3, Google Cloud Storage, so on, then assuming that the data is formatted appropriately, then we can query it. I have not heard of direct connectors to either one of those two logging solutions, but one could probably be fairly easily created as well.
Hey, Isla, I think
Well,
with the stack driver, it might, if you just push it to BigQuery, and then I think Presto could just read from that. But that's
There you go.
that may or may
That's a
not be in
fair
real
point.
time though, which is kind of the issue. So
Right. Yeah, if it does get pushed to a bucket, BigQuery can grab it. Thank you.
well, and ELK is Elasticsearch, right? So we have a
Oh.
connector for Elasticsearch.
Yep.
So Presto
we go.
can query Elasticsearch directly.
Sorry, I didn't. I don't know why I didn't recognize ELK there as Elasticsearch, but yep. Okay, let's move into talking a bit about use cases. This is really not what I would call a full list, I guess. I'm struggling to come up with a word, but some of the common ones here. The first one's interactive data investigation. Any type of sort of ad hoc analysis that needs to happen rapidly. You can scale the cluster up so that you can actually run those ad hoc queries with very low latency. And typically those situations arise, and where we add value is when they're federated, but it can be against a single source as well. Yeah, so that is probably one of the most common ones. A close second there, I think, would be BI dashboards and reports. So again, if you have something that can report that needs to get out quickly, and it's not in the data warehouse, or maybe it's some information that's already in the data warehouse that needs to be augmented with some that's not, you can actually build a BI dashboard or a BI report right up against Starburst Presto. We have customers who, from a data science perspective, they're actually connecting to Presto, to Starburst Presto. And those could be rapid queries, they could be long running queries, it doesn't matter. This gives them access to the data at scale, and we actually have libraries and packages for Java, Python, R, Spark, and so on. And then finally, because we talk so much about helping folks, kind of deal with the fact that ETL takes a long time, it might be surprising to see this one listed. But again, we're not saying that ETL doesn't need to exist. There are certainly good reasons sometimes to do ETL, to pre-aggregate, or pre-compute your results. And one of the nice things is that with Starburst Presto, you can do things like a create table as select, write your query and have that data actually be materialized, copied into a table for you at the time of creation. So if you do have something that needs to be, pre-calculated, needs to be converted and stored somewhere for quick access, you can actually use Starburst to do that. So just talking a bit about Slack, one of our customers. Slack was using open source, and they had some challenges with the total cost of ownership. They needed to scale their platform, to a level that can handle the kind of steady state workload, because they didn't have any auto scaling enabled. And this was just kind of doubly a headache for them, because in some cases that was too small. But then often, it was too big for them as well. And so they had a high cost of ownership relative to how much the platform was actually being used, but then they also couldn't burst to get the full performance that they needed during high periods of activity. And so, they were having just challenges with even low success rates on the queries running, because they were running out of memory, and they weren't able to quickly scale the environment up. And I forgot to mention at the middle point here, the other thing is that they had to self-manage this from an update and patch perspective. And so with Starburst Presto, as I mentioned in the kind of 5-6 things that you get with it, one of those is the monitoring and management capability that gives you auto scaling and graceful shutdown. So you can actually, you can determine when the cluster needs to be running, and you can bring it down when you don't. And again, this is all compatible with the 3 major cloud providers and their Kubernetes engines. And so you can really save some money by scaling the cluster down when you don't need the resources, and scaling it back up. They also got a high availability coordinator out of this. That's part of the enterprise features. And then they got role-based access control and integration with Ranger, which allows the the fine-grained security access and the data masking and such that's provided with the enterprise version. The other big thing is they actually needed less resources because now they've got the cost-based optimizer for these queries. And so, things are running more efficiently, less compute resources required. And that's, again, a feature that you get with the Enterprise Edition. And yeah, so they scaled to an 80 to 100 node cluster and had their queries completing, within seconds. So that is it for my talk on Starburst Presto. We've kind of hit all of these points that you can see up here. And yeah, I'll open it up to the questions from here.
Awesome, thanks. That was great.
Thank you. Yeah,
Sure.
appreciate everyone's time today.
Yeah, thanks everybody. I did drop the links in for the O'Reilly book as well as the Starburst T-shirt at the beginning of the Prezo. So they're at the top there. If you want to scroll back up, just want to make sure everybody has an opportunity to grab those during the meeting here. The shirts are pretty nice. They are actually one of my favorite shirts. So definitely grab one of those. Before we lose Martine or Curtis, are there any other questions, Starburst related, Presto related, any or all of the above? Awesome.
Hey, I have a question actually. My name is Kirkwood. I wonder, we've talked a little bit about the beginnings of Presto. I wondered if, I've always heard, sort of layman descriptions of what makes Presto so effective at connecting all these different systems together, and why is it so fast relative to older technologies. Could one of you reiterate that, maybe in a layman's terms?
Well, so I mean, there's multiple aspects to this. One is, if you compare Presto with things like Hive, why is Presto much faster than Hive, which is the thing we're trying to solve in the beginning? There are a couple of reasons for that. One is Hive is horrible code, so it's designed to be inefficient. And we were very, very careful at when writing the code for Presto to make sure the core of the execution engine was efficient, and it was code that the Java virtual machine could optimize effectively and into native machine code that can run quickly. The other factor is that Hive runs on top of MapReduce, which has a very pessimistic view of the world. And what it does is, after every step in the computation, it persists the results back to storage. And then in the next step, it reads them back and does something and then persists them back. This is just in case something somewhere happens to fail. With Presto, we decided not to go with in that direction. And we built something that is more similar to traditional MPP databases and query engines, where all computation happens in memory. Like Presto reads the data, does the computation. If it needs to send data between machines, it does it through in-memory buffers without having to touch storage. So that reduces the amount of I/O needed to execute the query, and reduces the latency, therefore. In terms of connecting to other data sources, that really depends on the implementation of the data source. I mean, of course, Presto won't be faster than, say, Oracle. If you're running a query through Presto that queries Oracle, you are going to be better off running the query directly against Oracle. But what Presto gives you is the ability to take data from Oracle and then join it against data from Hive, for instance, which you otherwise have no way to do unless you copy all the data from Oracle into Hive or vice versa.
Thank you.
Yeah, Fitz had a question. You mentioned temporal. Does it do bitemporal? I don't know if you want to elaborate on that, Fitz, or if that's clear enough.
I'm not sure I understand the question.
Yeah, so there's some engines are just temporal. There you kind of allow one dimension of, I don't know what the right term is, temporality. Anyway, I think like SQL Server is that way, but some are also bitemporal. I believe Teradata allows bitemporal tables, right, handling more than one aspect there. But if you don't know off the top, I can just look that up.
Yeah, I'm not familiar with the term bitemporal, temporal. So I don't know how it applies to to tables. So I'm not sure I can answer that.
Okay, thanks.
Yeah.
I did see KSQL, Kafka on the list there. What's the performance of querying directly off a Kafka stream versus regular KSQL just in Kafka?
I mean, what Presto will do is it will read data from Kafka and process with the Presto query engine. So it's a different use case. Like KSQL, I'm not super familiar with it, but as far as I understand, it's designed to be able to run persistent queries over streams of data. So this is a query where you have a continuous stream of data. You're feeding data into that SQL operation, and then I don't know, say every hour you dump a count or something like that. So I think they also support ad hoc queries over the streams, and I imagine they have that much better tuned than Presto querying from Kafka directly. But I think it fundamentally serves a different use case. And if you go through Presto, you also get the advantage of being able to join data sources. You can join Kafka streams against something else, or you can take advantage of the full function library from Presto, or even the higher level operations that Presto support, like window functions and grouping sets and things that I don't think KSQL supports today.
Cool, that's helpful. Thank you. Who else has questions? No one? Cool. Well, I guess it's a good place to end it. I'm gonna stop record, and I will wrap it up from there. So.